And now today's guest, Marcia Lovett. At the Eberly Center for Teaching Excellence, Marcia does one-on-one consulting with faculty, conducts workshops, works with department heads for faculty to develop faculty teaching goals. She very much enjoys the blend of theory with practice. As the director of the Learning and Problem-Solving Laboratory, she and her team research the question, what do people learn from solving problems? Many of our learners enter the university with little experience thinking about how they learn best or having tools to help them be more aware of thinking, reflection, and their learning. She's written numerous articles on how students learn and how instructional interventions can enhance student learning. As educators, Marcia says we tend to focus on teaching students content, but we also want to help students develop as learners. Metacognition, thinking about one's own thinking and reflecting on one's own learning, is essential to achieving both goals, and yet instructors often feel they lack time or expertise to teach their students metacognitive skills. Today, Marcia will share insights into teaching metacognition, including a Carnegie Mellon program where metacognitive instruction is integrated into first-year sciences courses, and a low-cost tool she has developed called Wrappers. Remember, if you have questions as we go along, please enter them in the chat room. I'll be sharing your questions with Marcia periodically during the session. And you may want to think about the discussion questions that are also posted on the ELI website. Marcia, welcome.
Thank you, Julie. And thank you, everyone, for joining today in this webinar. I will be upfront and tell you this is my first webinar to be presenting, so I'm really excited to be here and be part of the ELI webinar series. Today I will be talking about research and some strategies for teaching metacognition. But before I get into all that, I did want to give a little bit of detail on some things that might happen if you don't heed my advice. So the first thing is just a little problem that happened back in the day. You might have heard about a particular horse that arrived at the gates of Troy, and the people there basically forgot a metacognitive lesson of checking your assumptions. They said, hey, look at this great horse, and didn't think twice. So that's one of the topics that I'll be talking about today, checking one's assumptions. Another little problem that might happen is something that we might have heard about. The Titanic was this ship. It was thought to be rather strong, but unfortunately, some of the people involved in that didn't always take the metacognitive lesson of knowing your weaknesses. So that's another aspect of metacognition I'll be talking about today. Thirdly, a historical event. The Maginot Line in World War II was something where the French were trying to use the very best in World War I technology with bunkers and lots of concrete, and unfortunately, they forgot the metacognitive lesson of knowing when to adapt. So that's another aspect that I'll be talking about today. These three aspects of metacognition are critically important for learners, yet they're often overlooked. So to define metacognition, I'll talk about it as thinking about one's own cognitive processes. That is, thinking about one's thinking, learning, reasoning, problem solving, and so forth. And what I'll be arguing is that even though we generally focus our teaching on the content area in which courses are situated, metacognition is essential for effective learning, particularly in complex situations. So here's really the message I have today, that is, teaching metacognition is a really helpful way to improving our students. If we think about effective learning, it involves planning and goal setting, monitoring one's progress along the way, and adapting as needed. All of these skills tap into metacognition. So in the talk that I have prepared for today, there are 4 parts. The first part I would like to do involves setting the target. What really is the goal for ideal learners being effective at their learning? Then I'll talk about 3 areas of research you can see indicated here that are areas of inquiry where researchers have studied how we can improve students' metacognitive capacities. So first, setting the target. I'll start with an example of an expert versus a novice learner, in which case both of these students are going to be having a science test the day after playoffs, and their instructor has told them that it will be essay questions. So Emily, one of these learners, is slightly worried. She knows the test is the day after the high school playoffs game, and she knows that essay tests are a challenge for her. So she sets a plan to start early, outline the key ideas from her notes. As she's going through her lecture notes, she notices that a lot of the things she's studying have a cause-effect relationship, so she uses that to reorganize her ideas, and as she's going, she stops to self-assess. That's one of our learners. I think it's pretty obvious that's the expert one. The other learner is Monica. She's also anxious about this upcoming test because she feels essay tests are hard. Her approach is to just study harder. She reads and rereads the text, memorizes vocabulary, and doesn't really have an explicit plan or any goals to check against, with the exception that she decides to start the night before and then has the interruption of watching the playoff game. So you can see that between just these two little vignettes, we have some really big differences in the approach that these students take to learning. Looking at that in a theoretical way and looking at the ideal, a bunch of researchers have identified a set of processes they call self-regulated learning that really highlight the productive kinds of steps that Emily's story showed. And I have written that in a picture here that shows a cycle of 3 major stages. Starting at the top, have a learner planning and setting goals as the initial part of their learning process. Then from there, they go to apply strategies and monitor their progress in achieving the goals with those strategies. And given the monitoring process, students move on to being able to evaluate whether the current strategies are working, and if not, to adapt their approach, in which case they might go back to the top part of the cycle and set new goals or make a new plan. So that cycle is part of what we call self-regulated learning, because as you can see from those 3 processes, the learner is really doing a lot on their own and adjusting and regulating how they're going about that learning process on their own. Inside the cycle, the circle, you can see I jotted a few things down that actually play into this process and can affect how the cycle goes and how effectively self-regulated learning goes. One is the task constraints. So in planning and setting goals, it's really important to take into account the task constraints. In Emily and Monica's example, it was the biology test being an essay test that was part of the task. Someone's beliefs about learning can also influence this cycle, particularly influencing what strategies someone might take. Also, knowing your own strengths and weaknesses and having different levels of motivation are 2 other factors that affect the self-regulated learning cycle. That is kind of the ideal process that we're hoping students will ultimately gain and be lifelong learners. As you can see, metacognition is playing a big role in that process. Which leads us to the question, if that's the ideal scenario, and we know students aren't necessarily going to start out with such highly effective self-regulated learning skills, can expert learners be made? Can we teach our students? Can we help them develop in these capacities? As it turns out, early attempts in the literature, in the research literature, to teach metacognition mostly failed. Some examples are that students were taught some abstract study strategies, but showed they couldn't apply them very well to specific situations. On the other extreme, students were taught concrete study strategies, but in these cases, the students had trouble transferring them or generalizing them beyond the situation in which the training occurred, And thirdly, a lot of research showed that students' attitudes and beliefs were rather difficult to change. So this led researchers to conclude that, unfortunately, metacognitive performance is more of a stable trait. It's not something that we can really promote or foster in our teaching. That conclusion, however, no longer stands because there's a lot of new research showing that there are some ways we can help students improve in their metacognitive skills. And in particular, I am going to talk about 3 areas of research that are really encouraging, and I hope to share with you some enthusiasm about the helpfulness of these kinds of results. The first area I will discuss is the area of changing students' beliefs about learning. And in this regard, I want to start with a cultural situation that we had in America not too long ago, where the Barbie doll was espousing a certain belief. You can see that this could lead to have an effect on students' learning and their productivity in learning if students hold certain beliefs. And I think this is about the time we were going to pause for some, nope, not quite yet, pause for questions. I'll do a little bit more talking. So beliefs like the idea that math is hard definitely can have consequences. If you think about the self-regulated learning cycle I discussed earlier, one example is to think about learning as quick and easy versus hard and effortful, toward the bottom of my slide. If someone has that belief, one could have very different strategies or very different levels of perseverance in how much they keep trying to apply certain strategies. Also, if someone believes that being a good learner is innate rather than a skill that develops with practice, well, that's something that also could affect how likely a student is to try something new and adapt their learning strategies. So these are just